All right, guys, we're continuing with our GM 4L80E automatic transmission rebuild. Welcome to part 4. We're going to pick this up with continuing with our fourth clutch. So actually we're at that stage now where we left off in part 3, where we actually need to partially disassemble it, right? So for easier installation of the Overrun clutch housing, GM recommends that we take the backing plate retainer, backing plate, and clutch plates all out of the housing, and then put the housing in to the transmission case without all those internals, and then we'll build this clutch up over again around the Overrun clutch when we get that installed. We'll also be grabbing our bolt part number 26, and they give you the torque value between 17 and 19. I usually split the difference and go 18 foot-pounds on this. I won't be torquing this bolt though until we get the other pieces installed, including checking the pump. Just in case something is off from that forward piece down, we won't have to toss these bolts. These bolts, just like the one on the center support, think of them like torque to yield. You can only use them one time. If you take them out, you're going to have to toss them. So don't torque it until you're sure you're all done. All right, so let's go ahead, and I also switched for the rest of this to the 99 version of the unit repair manual because some of the diagrams in that aren't exactly correct on the 98. So I want to make sure as we go through here we have things that are more appropriate to what you're seeing. All right, so we're going to bring our fourth over here, and now we're going to have to partially disassemble him. So we're going to start with getting this snap ring out. I might have to get a larger tool. We'll see. Maybe not. All right, there's the ring. Take our plate out. Take our whole stack of clutches and steels out. And then what we're going to do is we're going to take some trans gel. We're going to come over here to the case. And we're just going to lube up around the perimeter where this guy's going to sit. Kind of ease it going in for us. And then you just want to take note of where that bolt hole is. Right, so that bolt hole is right here. It's going to retain this guy. And if you don't remember what he looks like, right, this was part 26 that we took out. And we check our rebuild kit, we're going to find we've got a replacement right there. And we'll mark off which part number this is in a moment. But there's our replacement 26 bolt. Take this housing with that bolt hole facing in the proper direction. And we're just going to get him seated back in here just like that. And you can just kind of rotate this around until you can see that the hole is in the right position. And there he is right there. And we're just going to take our bolt and just start the threads. Like I said, we're not going to torque him. We just want to start the threads. All right, and that is it for this step. Now we move on to the Overrun. All right, next up is the Overdrive carrier assembling. Now, in our case, 514 was damaged. So you remember in the disassembly video, I showed you how to remove this retainer 520 and this retaining ring 521 so that you can get inside here and clean and get these guys ready to go. And when we were doing that work, we actually got as far as disassembling and cleaning each one of these. So if you remember from the service manual on the disassembly, you have to do them one at a time because you can't mix the parts up. Each one has to be done one at a time. Then we had noticed that we had that spun bearing that went into the forward hub, and you can see all the burn marks from this where it had gotten stuck onto here. So because of this and the fact that it has been heat damaged, we elected to replace this whole unit. So I'm not going to be showing you disassembling this, but we're going to replace it actually with EC Delco 24215530. So this is in a little bit of a different packaging because it came from an AC Delco distributor, but it is, you know, there's the difference between new and damaged. Now, could you have taken this to a machine shop and polished it up? Maybe. Would it have fit the bearing properly? Probably not, and they don't make oversized, I'm assuming the bushings, but they don't make oversized bushings, so we went this route. So if I had put it back together, though, at this stage, I would be installing a new 513 bearing and then 512. Now the parts they talked about over here where they say, hey, keep everything, washers and bearings together with the pinion carrier gear and pin. Don't let them get separated. Everything basically stays in its original location the way the factory put it together. But you can disassemble them one at a time and clean them and then reassemble them one at a time. And then you would have put this plate 520 and 521 back on. You would have been done with this step. All right, next after that, we've got the Overdrive carrier assembling. So part 504 and 514 are going to go together. So here's our cleaned and restored 504. But before we can continue that step, we've got a couple more bushings to do. There's a small bushing on this end, and there's a larger bushing on this end. Now, to get that swapped out, what we'll end up doing is we'll end up replacing the small one with a Durabond 8623944. This is an example of an earlier GM number that's just being recreated to fit in here. And we'll be replacing the larger one on the other end with a Durabond GMT 4-2. Be the guy we put in down here. Now to get this small one out, it's no big deal. We'll use our bushing driver set. We'll put a 25 on the inside diameter and a 28 on the outside diameter. Right, so that'll give us something that will fit flush inside there and catch the bushing, but we're going to actually drive it from the inside out. We'll be able to drive that out that way. That's no big deal. What you want to do is just take note of whether this guy, just like all of them, you always want to take note of whether they're mounted flush or whether they're inset. And we can see this guy is basically mounted flush. The larger one, though, is going to have to be more of a caveman tactic. So we're going to go ahead and try first with our blind hole puller. And we'll go ahead and put this in here. I don't have a lot of confidence in this, but you know, it does work sometimes, right? I did a transfer case rebuild recently. You guys may have seen that video, and these tools worked just fine for those smaller types of bearings. They don't do as well, in my opinion, on bushings. But what I'll do is I'll get this guy tightened up, have him grab on, right? We want to have him grab on, or if we pick it up, you know, it won't let go like it just did. And then I'll show you trying to see if this can pull it out. All right, guys, you know, basically you get to the point where you can pick this up. I like to get it where it's still turning just a little bit, and then just give it a small additional tightening just until it becomes hard to turn, but you don't want it so tight that it's not turning at all, because then it'll be too tight against the inside bore. So that's probably a good place to start. This is another one where you want to take note of, is it pushed in flush or is it pushed in, you know, with any kind of an inset. And this is another one that's pushed in flush. I'm going to lay a couple of pieces of wood to protect our metal, and then we're just going to mount up this tool here for the press. Basically screws on the top of this guy. Seat him all the way down. And then we'll go ahead and get it mounted flush. All right, guys, as expected, the puller, it's just not really a great puller. You know, if they had like 4 prongs on here, even 3 prongs, it would be better, but it tends to walk. However, I think we can still use this tool because we did raise it about 1 millimeter or 2. So what I'm going to do is I'm going to leave this guy in there, and I'm going to switch to using a brass drift. I'm going to hit the bottom of this guy while he's all expanded, and I think we'll be able to use it to drive it out that way. I want to pop this in the vise, but you can see she's going to work out. So she's working her way up. So we're going to put this back in there and use that technique to get this out. And another technique I could have tried, but I didn't have the right one. You can sometimes get one of these rolling type pry bars in here. This particular one I have is just a little bit too big for this. And I don't know, I might, you know, if I don't get where with what I'm doing, I might just grind off a little bit of this so it'll fit down past that lip and rest on the bottom. And that's another thing that we could use to hammer this out. But there's two different ways you can get this out with. But the idea is you don't want to try going down, and you got this recessed area, so you can't do the deform technique that I showed on some of the other pieces. We've got to get it to come out this way. Because of the shape, we can't really get a punch in here because it's not going to deflect properly. So one of the two ways I'm doing is really the only option we have. All right, that one's out. I don't know if our hole's the right size. Yeah, we're fine with this. Almost. All right, that one's out too. So not what the tool was intended to do, but it served its purpose so we can get this out without having a whole lot of damage. So that way we've got absolutely no marks from tools and that sort of thing. We'll blow these little bits of brass that came off of our drift, and we're ready to put the new ones in. So we're going to put the new ones on the press. Quick look at our old ones here. So you can see again, there's the FM mark, and this one has an FM5. All right, guys, let's get this bushing in. This is a bronze bushing. You can see that 8623944 is printed right on the outside edge. And we're going to be putting that in with a 25 and a 32. We're going to go with a larger outside diameter just to make sure that we can get it flush. And just like all these other bushings, we're going to give it a little bit of Loctite 640 on the outside, just to help make sure that it stays put and doesn't walk. All right. And we've got the whole assembly sitting on a piece of wood here, just to avoid marring the steel surface. All right, that's it. Okay, that's one. Then we're going to flip her over and get our tool adjusted to do the other, but we can see that's sitting in just the same position that the original one was. All right, we've got our setup flipped over. We're going to put our GMT 4.2 Durabond bushing in now. And just like all of these, right, it'll be marked with the number on the side and USA. Same Loctite treatment around the outside diameter. Also, I didn't mention it, but make sure you get some brake clean and clean the inside bore out where you remove the old bushings, just to make sure that it's nice and clean and free of any solvents before you get going. All right. It's kind of a thick coat, a little bit thicker than I wanted to do here. I'm going to get this guy in here. We'll make sure he's not cocked. I'm just going to kind of try to push him in a little bit by hand so he's sitting like that. And then we're going to push him in with a 47 millimeter on the inside and a 55 on the outside to ensure we can get it sitting flush. Raise our equipment up here just a hair. Or we might need to lower our thing here. Let's see. Let's see if we can get this done without having to lower it. Yeah, okay. I can tell she's a little bit cocked in there just by seeing how the tool is sitting. So I want to try to correct that first. This one, you're kind of blind. You can't see anything. So you just got to hope for the best. If for any reason it feels like it's not going in straight, I just will quickly abort and counter it on the other side. There we go. Now we can get her back in straight and drive her home. And you'll be able to tell when you've got it flattened out just by the way it feels. And that's another one seated and ready to go. All right, now that we've got our bushings, let's go ahead and assemble the Overrun clutch. So they talk about having a J38729 seal protector, a 38734 spring adapter, and then the usual mousetrap 23327 piston spring compressor. When we get to that point, we're going to be using aftermarket parts, although I do not have a seal protector, so we're going to have to get by with our lip wizard. So what they want us to do is take the clutch piston seal and lubricate it and get it positioned onto the housing, right? So we've got the housing sitting like this. We've got our old piece 505 that they're talking about, and we're going to be replacing that with a new GM part 2420-2092. This is a bonded type design, so this is all together one piece. All right, so we're going to get this guy nice and lubed up. All around. And then we're going to very carefully, since we do not have the tool they're talking about, we're going to position this guy in here and get him just on the smooth end. Get him into position. This one's pretty easy to do, right? There's not a whole hard problem to this guy. And then they want us to put 506 in. Like this. And actually take this guy out a second. Right, we got to get him down where the retaining ring is going to be able to fit. So we're going to end up pushing this guy down enough to get that retaining ring right in there below where this roller clutch is going to sit on the 514 piece we worked on earlier. So let's go ahead and get our spring compressor set up, and what we're going to be using for the retainer is we're going to be replacing the 507 ring with an 866 1568. I have to get that guy opened up and get him on there. All right, let me get some of this stuff cleared away and we'll bring our spring compressor over. All right, let's go ahead and get this spring assembly compressed. This is our last use of this tool in this job. It has done a fine job for us in this project. Make sure we got that guy where he goes. Problem I always worry about on these things is, getting too much force on them. All right. Old friend, Mr. Snap Ring. I'm just checking to make sure. You see this little nub here. You want to make sure the ring is inside these nubs before you take the tension off. It's like this one here. Yeah, he's fine. He's fine. He's fine. Okay. All right. Now we can build up our clutch pack. We'll replace our spring compressor with our dipping station. What we're going to be doing now is just like we've done on all these other clutches, right? We're going to be stacking frictions and steels. So here's our steels, 508. Our original ones were in great shape, so we're going to be reusing them. Here's our backing plate, 510. We're going to be holding that all together with 511, and our replacement 511 is an 866 1572. And of course our frictions we're going to replace with our rebuild kit ones. So 509, we're going to replace these small ones from our rebuild kit. And let's see, that part number is these guys right here. 1, 2, 3. Is it 3? Yeah, it's 3. Thought it was 4. My bad. And that would be part 509, and we can go verify our part number. 509 is 866 1571. 3 of 866 1571. So we're all set. So let's get our dipping station set up. We're going to mark our bag that we use this, and we'll cycle them in. All right, as usual, we're going to start with a steel. Always start with a steel. No particular orientation on these. And a friction. And we'll keep alternating around, friction, steels. This is a small clutch compared to all the others we've done. One more of each. And again, guys, you know, like the service manual says, you just dip it. This material is not porous. You can't soak any fluid into it, right? You just want to get it coated on the outside. The backing plate on this one is marked up, so we want to make sure that is in the up position. And then if you've installed everything correctly, you'll have the groove exposed for the ring, which we do. Try to get it in by hand. She's fighting with me. Might have to get it. Little pocket pry bar deal here. Come on. Sorry about that, guys. I don't know why this one's being particularly stubborn. going to keep our fingers on it until we get it all the way seated, though, so she doesn't go flying in our face. There we go. All right. Now the next step on this, so we've put the retaining ring. Now we're going to go measure the piston travel. So we're going to grab our feeler gauge, and just like we've done on several of these, we're going to measure the distance between the top of the backing plate and the retaining ring. All right, so we're after a number between 33 and 94 thousandths. And we got a snug fit under here. You could probably go one lower, but I'm going to go with 30, 25, 10, 65. So 65 thousandths is in spec, so we passed this piston travel checked. All right, so the next thing you would have done here is a pinion end plate check on the Overdrive carrier. All right, switching to the 99 book because it's a better, easier procedure. This end plate check was done with a dial caliper back in 98, but in 99 they went to this feeler gauge piece. So we're going to grab our 514 Overdrive carrier, and I've already pre-did this. Even though this is all new, we want to check that because even though it's new, it might have a problem. And we're going to slide this in between the washer and the pinion gear. And we're going to see what one we get in here. In our case, we can get a 14 thousandths in there. And if we reference the manual, we can see that anything between 8 thousandths and 25 thousandths is okay. So this test passed. All right, earlier we already talked about, since we've got a new NOS assembly, we don't have anything to assemble with the Overdrive carrier. If we did, we would be putting in a new bearing, but since it's new, it already has one, and we would have been disassembling each of these individually and cleaning, like I mentioned earlier, then putting in the plate and a new retaining ring here, 521. But again, ours is all new, so I have nothing to show you here. And lastly, the Overdrive clutch roller assembly. So, that's this guy here, 512. This is the old one anyway. I'm not going to put this in the way they suggest, right? They suggest to put it in here and let it sit before it gets put back on top of a 509. But we're not going to do it that way because it actually is a lot harder to do, in my opinion. So we're going to skip ahead to bringing these two pieces together. Now, this assembly here is discontinued by GM. And I had half a mind to put the old one in, rather than an aftermarket piece. But if you remember in part one at the very beginning, I said there was one aftermarket part besides the Durabond bushings that I ended up having to go with, and that is for this guy. And so what I ended up going off with here is from Raybestos Powertrain, a 200-130. Now this particular part I'm showing you is only used through 2001. After starting in 2002 up until the end of the line for the 4L80, it was a different type of roller clutch. It has like some blue plastic retainers, and these rollers are smaller. What you always want to worry about on these guys is whether you're getting the right size. Some of these no-name brand ones are pretty concerning in terms of how big they are. So the diameter on this guy, on these little rollers, actually we want to go to inches here. You want to see like 31 hundredths or so. 310 thousandths rather. If I can grab it properly, .312 is probably just me jittering here, right? What I want to make sure is I'm not seeing something that's less than 310, because there's a chance that it would not work properly. The purpose of this part, if we grab the rest of the assembly, the purpose of this part is to sit inside here and only allow this to turn in one direction, just like these other roller clutches and sprags. So we're actually going to install them in here first. Just going to give them a good spritzing. I'm running low on my spritzer. And then we bring these two together. What we're going to be having to do is overcome a couple of things, right? We got the usual situation where we've got to get the teeth of the frictions lined up so that we can get stuff to fit. But then we've also got to get it around this guy without breaking him. And he's somewhat fragile, right? It's a piece of plastic, right? If you damage it, it could be a problem. So the idea here is we're going to try to come in like this, always turning in a counterclockwise direction. So we can get past this first part. Like everything else on this project, guys, you just got to be patient. Got to be patient. There we go. All right. So now we're starting to get it in. And what you should find is it turns in this direction, but it won't turn in the clockwise direction. So that means the rollers are intact. Now we just got to get it worked on all of these clutches. There we go. And we'll know it's up because it's got a little bevel at the top, and that bevel kind of flanges off with the top of this retaining ring. So at this point, we've got this guy assembled. All right, now we move on to putting the turbine shaft with this piece. So that's 502. So we reconditioned this earlier with our new Teflon seals. Right, so you just want to always inspect these guys and make sure that they look good. They're not torn, bent, or damaged. Once again, we're going to give some good lubrication on this wherever we're going to have a bushing or a bearing. All right, there's another piece to this I'm going to show you. Let me lay this guy down here for just a second. And so this ring here, 522, that's this guy right here. We're going to replace him with an 867 5523. And we're going to be slipping all over the place trying to open these packages. All right, we're going to go grab our snap ring pliers, and we're going to put these two together, and we're going to secure him in this groove right there. So that's how far we're going to run him in. All right, now we're going to take this guy, kind of lay him sideways. We're going to run this shaft up through here and out the other end. And we got new bushings and all, so things are kind of tight. All right, and then we're going to take our external snap ring pliers. I'm going to open this guy up, slide him into position. You just want to make sure you hear him click into position. And just inspect him that he's seated all the way around, and this assembly's done and ready to go inside the transmission. The only other thing I'm going to do before we do that is I'm just going to spritz up these pinion gear washer mating surfaces all the way around because I neglected to do it earlier. And at this point, we're ready to put it inside the case. All right, guys, so now we're going to take this Overdrive, Overrun, very carefully because of our Teflon seals. We want to get it situated right down into this bore. Make sure everything feels like it's turning okay. And now we can rebuild. We'll go get our fourth clutch pieces and we'll rebuild the fourth clutch around this guy. All right, we'll just rebuild this guy here. Remember, the notch piece goes to this small opening that's directly across from the bolt hole down here, right? So now we get these guys to fit on the teeth without fighting with them. It's the hardest thing on this whole operation is alignment of these various teeth and clutch pieces between different subsystems or subcomponents rather. All right, and then this big guy is going to fit up here and fit around this lug. If I don't get him in cockeyed, there he goes. And then we're going to put our ring back in. And the ring has a tendency, if you start it on this side, to kind of protrude in this open area. So I like to start it on this side. Come on. It's not quite in over here for some reason. There it goes. There it goes. All right. You always want to hear that twang to know that you got it in there right. All right. So we got this guy in, and there's a test that's in the service manual that I'm going to show you right here. All right. So in the manual here, they talk about placing a straight edge from the oil pump mating surface over to the Overrun clutch housing thrust washer 218. This is the plastic washer that goes in here, and it's selective. So this is the front end play selective washer, and the two surfaces should be flush. So we're going to go start with the washer that we pulled out because we don't know if we might be fine with that one or we might have to change it. So to start with that, see if we're flush. I'll go over some information about these washers. All right, guys, see, here's our original 218 thrust washer, and we can see on the edge, I don't know how that comes out because this is an old worn part. It's got a brown paint mark here. That's a colored indicator as to its size. And all of these other ones that I have, 867, 75, 71, very similar, right? This has got a white mark. 867, 75, 72. This guy has got a red mark. It's really hard to see, though. And 73 would be the brown one we have. 74 has a green mark. And then the thickest one, 867, 75, 75, it doesn't have any mark at all. And so just like with the rear selective washers, you pick which one of these gets you where you need to be for the end play. But we're going to put the brown one on for now that it came with. And then we're going to run this guy over here. And what we're going to see is we're not flush. You see, we've got a gap. So this guy is sitting up. So what that tells us is something is not fully seated in this stack. And this is exactly why I said we don't want to torque down that fourth clutch bolt yet. So we're actually going to have to take some of these pieces out and figure out where our problem is so that we can get this guy like this, right? We got to get him flush like that. All right, guys, we got this to where it needs to be flush with a straight edge. It turns out I just gave the shaft here a turn when I was getting ready to take it out, and the Overrun assembly dropped down one more, measurement into the forward, and that was all it took to get it where it needed to be. So, fortunately, we don't have to take anything apart. We're done at this point with all of these clutches, and now we move on to the pump. All right, first thing we're going to do on the pump is this test that we skipped at the end of the disassembly video, which is a transmission oil pump body flatness check. So we're just going to take the body, 203, that we've got all cleaned up and restored and ready to go. We're going to take a machinist grade flat edge, straight edge rather. And we're just going to come across with a feeler gauge. There's no particular size on this. So we will just pick something here to start with. And we're just going to see if she's uniformly the same size for the two pieces to mate together, right? I'm not able to get a 25/10 in here. So that's really all I'm after here, is I'm just trying to see, do I have any gaps? And if I have something smaller than 25/10, I can do that. Might have something smaller, let's see. Yeah, we can go with 2/1000. But I'm pretty sure that we're good on this test. So we don't want to see anything, or we'd have to get a new pump body here if we had anything coming through here. All right, that test passed. Now, the next test, we're going to go back one page. This is the trans oil pump body to gear face clearance check. Very similar test. But for this, we're going to need to install our gears. So we got 204, which is our outside gear. We got 205, which is our inside gear. This guy we're going to install with the dots up. And it's the same type of test, although they've got a specific range that they're looking for. And for this test, and I like this Lyle 68100, got a little bit of a breeze out here today, 6100 set, because it's got just the right sizes. So I'm going to start with this 25/10 one, because the maximum we should have here is 28/10. So we're looking between 8/10 and 28/10. These are 10,000ths. Notice there's 4 positions instead of 3. So this guy, all I'm wanting to say is I'm going to make sure I do not have the ability to get this 25/10 gauge under here. That's all I really care about. I don't really care what the actual measurement is. I just want to make sure I can't get this under here. As long as I can't get this under here, our wear is fine. And I cannot. Now, could I get something smaller? Yeah, probably. But I don't care. Because if this isn't going in, then we're nowhere near the maximum, which is 28/10. All right, so I'm going to try this in a couple of different places, as you see. Can kind of almost a hair, maybe, kind of wants to squeak on right there, but cannot actually get it to fit. So I'm satisfied that we've passed this test as well. I'm just going to spin it around, do one more quick test. Now, if this is a problem, what if you fail this test? What does that mean? Well, it means you need new gears. GM didn't service the gears separately, so that means you're going to have to buy a whole new assembly here to get the gears. Aftermarket, they would make just the gears. All right, we're good. We're past this test. Now what do we do? Well, before we can start assembling the pump, we've got 2 more final bushings. We got one here. These over here. So we got one here that's pretty easy to push out. We'll just push it out from the front here. And we can see that he's mounted flush. Then on the stator side, we've got this little guy right here. We got to get out. And then we got a guy right there. So we've got 3 more of these bushings. Now this larger one that goes in the pump body, we're going to replace with the Turbine 34001 CBR. This is a special version of this 3401 bushing that is solid brass. And that's what I prefer for this. You can get the Babbitt type, which would be a 34001C without the BR on the end, or the BR in bronze. Bronze, brass, I believe it's bronze. Or I believe it's brass, rather. These other two, this guy here is going to be a Durabond 866 1614. He's going to go right in there. We can see here, this guy is inset, so he's not flush. He's pushed in. So we're going to get out our measurer and find out how much that is set in there before we take it out so that we can get the new one in exactly where it goes. The way we're going to remove this one is we're going to go ahead with a blind hole puller like we showed in some of the other assemblies, and we're going to knock it through this side. So we're just going to use the blind hole puller as a way to grab the bottom of this bushing. So let's go get set up and we'll start removing these. This little guy here is going to get replaced with a Durabond GMT 41. And this guy will be able to push out in the conventional way with our bushing driver set. We'll be able to come in from behind here and get him through the bore. So 2 easy ones, and then the other one not so easy. All right, we're going to push this one out with a 50 on the inside diameter and a 53 on the outside diameter. That should get us through the bore without getting stuck in the bore. But we will pause and check to make sure as we go through. All right, so whenever I'm doing something like this, I like to just do a couple of hits, make sure she's not so big that she might get stuck in the bore before going any deeper. Okay, that one's out. Take a look at what we got here in our little catch bag. And we see, like usual, we got an FM mark. When we look at this old bushing, we can see there is some wear. So one side is nice and worn through, the other side is not as worn. All right, let's go do the other two. All right, before we take this one out, if we zoom in here, we can see this one is inset from the edge, so we're not going to mount this one flush. So we want to see about how far the factory had it in. So we're going to take our dowel caliper, make sure we're zeroed out here. And there's an edge on here that we can use for this purpose. So we're just going to slide this down. And I'm going to take a couple of readings. We've got 6.2. We're not looking for anything super exact here. This one says 6.4. We're getting a rough idea. 6.4. 6.31, right? So somewhere in that neighborhood. I don't know why this side was so small compared to the others. We'll do it again just in case we messed up. Now that one just seems to be a little bit less. Maybe there's some wear on that edge. 6.27. It's like a dip here. Maybe a little indentation when it got installed at the factory. All right, that still tells us enough to know what we're going to do. Now, if I was going to push the new one in, I would use a 28 on the inside and a 31 on the outside, because that's nice and going to keep us from mushrooming. But I can't fit that size through on this end. And so what I'm going to have to do is a 29 and a 28 and hope coming through this side that we'll catch it enough to knock it out. So that's what we're going to try and do here. Some other stuff out of the way. All right, that guy's out. Very similar to all the other ones we've seen. Again, FM mark, single supplier GM for all of these. Now this guy is also inset a little bit. So we'll do the same thing to see how far. It's like 3.4, 3.5. That can't be right. 3.7. Yeah, so I guess this is, some of these just have a low point and a high point on them, 3.7. This one's actually kind of like giving the impression it's a little bit cocked in here. Yep. All right, so we've got a rough idea, though, where it's going to go. We're going to take our blind hole puller, and we're going to tighten this up. Like you've seen me say, right, you know, I find this guy works great for bearings. Does not work as great for bushings. It's just too thin for it to grab onto, but we had some success using it with a punch, so we're going to try that again. So we just want to capture this enough to where we can drop a brass drift in here, and we'll try to hammer it out that way. Yeah, so our tool let go on us right there at the end. Almost got it in one shot. So let's just loosen it up. Reposition this back in there and finish it off. All right, one last hit and that is out. And once again, expect to see an FM on here. Yep. So, actually no, this one might be another mark. I can't make it out. Might be a different supplier. Or this might be a very worn FM. Yeah, I guess it's just a very worn FM. All right, got all these out. Let's get the new ones in. All right, let's get our pump body bushing on. This is our 34001 CBR. And again, make sure, just like on all of these, that you've cleaned the inside bore out with brake clean to get rid of any residual contaminants. Here we can see on the outside of the bushing, as always, it's laser etched. 34001 CBR USA. And we're going to use our Loctite 640 to help hold it in. Now this bushing, I don't know if you noticed when we were showing it earlier, this bushing, like the rear case bushing, is factory staked. So you remember we did the rear case bushing. It had a couple of dimples that helped press it into the aluminum side of the bore. What this one's got is an actual staking procedure done manually into two of the grooves on the opposite side. So if we look at the old bushing, we can see that here and here. And we're going to have to replicate that after we get this pressed in. All right, so spread this stuff around. Get this guy down in position. And we're going to be pushing him in with a 50 on the inside and a 56 on the outside. And this one is one that we want to get in flush. And we've got our pump body sitting on plastic and on wood, because we don't want to get any kind of marring or denting as part of this process. I'll throw the cap back on our Loctite before it ends up on the floor. We just want to get him sitting nice and flush. It should be right there. Perfect. All right, now let's take him back over to our work table and I'll show you how to stake him. All right, guys, so here you can see the staking indentations in the pump body on either side. What I'm going to use to do this is a special kind of punch that's got a rounded tip. This is typically the kind that you would use to drive in a round rolled steel pin, right? But we're going to use it to get a nice edge on this stake here instead. If I can get him to stay put. That's all we need to do. We just need to dent it in so that it can't spin around. Okay, that's it, guys. All done. All right, guys, just to zoom in here and let you see the final product up close as we can get. You can see that rounded tool does a really nice job at getting this in here without deforming any of the contact surface area, which is important. You don't want to deform the whole thing. You just want to get it staked at the top. All right, guys, now it's time to talk about our torque converter. So we're going to be replacing our old torque converter with a rebuilt GM 2421-7609. GM makes a lot of different torque converters, even for the same year, which is a big difference with aftermarket. Usually it'll be a different torque converter for each engine, sometimes even for each year. This is the one for ours. It's not necessarily going to be the one for yours. And the reason I'm showing you the torque converter now is now that we've got that bushing in to the pump body, we need to test fit it on our new torque converter because we need to determine if we have to size that bushing. Now usually with these bronze ones, they fit just fine. It's usually only the Babbitt type that I have to do that to, but we just want to make sure. So we're going to take our pump body and we're going to sit it up on top of our torque converter, and yeah, perfect fit. Excellent. That's what we want. She's very snug, but she's not binding. We don't want it to bind. It's okay for it to be snug. All right, that's it. We're good. All right, it's time for our GMT 41 bushing. And there's the writing. So we're going to put our Loctite 640 on here. Spread it around. And then we'll be pushing this guy in with a 31 on the outside and a 28 on the inside. We got this sitting on a couple of pieces of wood. And then underneath the wood, we've got some metal adapters. So with these small bushings, the ones that are really prone to cocking. So I just want to try and get things as centered as you can going in. Now, I'm going to change it to a larger one on the outside to set it flush, and then we'll switch back to this one to push it in. The reason for that is just to avoid any possibility of mushrooming. All right, guys, we're just going to use a 33 deflusher. So I can't see her. And then we'll work on a smaller size to get her inset. We're going to aim for 6.3 all the way around. All right, so the inset turns out, if you got the same tool I have, ends up where you're going to end up having it go in right to the middle of the 3 there. Hopefully you guys can see that, right? And that'll end up sitting her down between this 31 and 28 that we went back to. That'll end up getting us this inset of about 6.3 millimeters. All right, let's go do the other side. All right, we're going to run our 866 1614 bushing in now. Hopefully that's coming through okay. But they're all printed on there along with USA on the side. We're going to run it flush with a 35 and a 41. Last bushing. And again, on the inside bore, you want to run brake clean through there so you got a nice clean surface for this process. Run this guy over here. Hopefully we can get this in here without lowering it. She may be up just a hair too far. Yes, unfortunately, she is up just a hair too far. We're going to have to take our wood out just to get things started. And just like always, guys, we just want to make sure that she's going to run in nice and true without cocking. Okay, we'll run her flush, then we'll switch to a smaller size and we'll inset her. All right, guys, if you take a look here at this top driver where the 3 and the 9 are sitting, that'll give you an idea of how much the inset ended up being here. We aim to put her in uniformly around 3.6 inset from the top. And that is the last of our bushings, and that is also the last of the time we have in part 4. So I'm going to have to call it at this point. Call it an end to part 4, and we'll pick it up again in part 5. If I taught you something today, you got entertained, you found it useful, it saved you some money, how about paying it forward and hitting that like button for me? I'd really appreciate it. If you got comments or questions, leave them below. I'll try to help. And as always, thanks for watching.